All right, boys and girls. Hello, Mr. Parcher here. Good to see you again. I jotted down a few names of shapes and the shapes that I wanted to go over today, and some ways that you could recognize them. I guess it doesn't necessarily matter right now whether or not you can name them all, memorize all these sides and things like that. I just wanted to show you something actually is that the pyramid and the prism. So a pyramid would be a shape with four triangle sides and then a rectangular bottom, like the pyramids in Egypt. They have five total sides, and so does a prism. And I think you've seen prisms before. They have two triangle sides, and they also have three rectangle sides, and like two red triangle end caps, and then three rectangles going around. It looks like a tent. Reminds me of a tent. So and that also has five sides. So the ones with triangles end up having five sides. That's my larger point here. The one that I'm trying to get across is that the triangle ones, anything that has a triangle has five sides. In the examples I'm going to show. And the cubes, which basically just 3D squares, a bunch of squares in 3D, six sides, six equal sides. That's the main thing that makes it set out, is they're all equal. The rectangular or cuboid is a 3D rectangle. It also has six sides. So if you see nothing but if you see the rectangular cuboid, that 3D rectangle, is kind of like a cereal box is what I think of it as. That's six-sided. And then cube, what cubes look like, Rubik's cubes, things like that. Six equal sides. All right, so I'm going to show you the pyramid first. You could try to draw them. I suggest trying to draw them. It's kind of fun, and you've got a lot of time on your hands right now, so you might as well. One of the keys to drawing this pyramid is get the middle. You're kind of like making a tripod here. Make the middle line a little longer, and then connect these. And it looks that, and then you really just have to draw the back of the square here. And we're going to draw dotted lines because it's technically, if this was see-through, then you would see it, but not that. So that's the back to square it off. And then this would be the line coming up because, of course, this is supposed to be a triangle, and you would see that. You might not see it depending on how you're holding this, but I wanted you to see that it was there. So all these sides, the height of the triangle, so to show you that, the height would be, show you it's a right angle, the height would be 6. So if I said that was 6, and this base, what if I said all these were 4? And so that means that this is a square that's 4. So you might say, okay, well, the square is 4 times 4 for the surface area, right? Yes, it is. So the surface area of that square down there is just 16. And that was just 4 times 4. Now, for the surface area of a triangle, a couple videos ago, I showed you how to find the area of a triangle. It's half the base times height, or half the height times base, either way. So you could say half times the height is 3 times the base, which would be 4. All these are 4s all the way around, all these lines. So 3 times 4 would be 12. Or you could say half the base, which is 4. Half of 4 is 2 times 6 is 12. So just to take you through that thought, half times 6, and then times 4. So half of 6, which is 3 times 4, equals 12. So there's 4 of those, though. Keep in mind there's this triangle here, this triangle here, this back triangle here, and then the right back triangle here. So there's 12, 12, 12, 12. And if I said these were all centimeters, then when I multiplied, I would say that they're all centimeters squared. And then when I add them all together, they're going to be centimeters squared. So it'd be 12 plus 12 plus 12 plus 12, or 12 times 4 is 48, plus 16, which would be 48 plus 6 is 54, plus 10 is 64. You could have added them all up if you wanted. 8 plus 6, 14, carry the 1. And it all adds up to 64 centimeters squared. All right. So next one, I wanted to show you a prism. This is the one I found the most difficult to draw, because the key is actually the one that I'm trying to draw. The key is to make that a very kind of like short looking pyramid, like short and wide. And then this is what if I call this 1? And then if I draw a rectangle on the bottom, that's something you can see also. And then, so I've got all this. The part that you wouldn't see is how this line comes down. It connects to this. And then there would be a triangle on the bottom. So it would be that prism because it's two triangles. Triangle on the bottom, triangle on the top. And then there's also the rectangle here. But what if I said 1 centimeter, this rectangle, I will say it's 2. And this is the hard part about this triangle, is I can never make this back one look like a rectangle until I fix it. Looks a little bit more like a rectangle now. Like when you look through here and you look at this rectangle back here, now it kind of looks like a rectangle, but it didn't before. So what if I said this was 4 and this was 2? I know this might not look twice as much, but just bear with me here. And then what if I said that this was 3? All right, boys and girls, so you have 2 triangles. The height, we're going to say, is this line here that's 1 centimeter long. So 1 centimeter. And the base is going to be, you can see that also this height would be 1 centimeter. The base is going to be this 4 down here. So if that's 1 height and base of 4, you got to take half of one of them because it's half of base times height. And this one I would take half of the base because half of 4 would be 2, and that's a lot easier than working with a half, because half of 1 would be a half. So half of 4 is 2, so it's 2 times 1 is 2. So your 2 triangles have an area of 2. This triangle is 2, that triangle is 2. Then I have rectangles all over the place here. So there's a rectangle on, I don't know what you call this, the back left rectangle. 2 times 3 is 6. Well, this one, the opposite triangle, is going to be the same size. That's also going to be 6. And of course, remember, it's 5 sides. The 5th side would be this rectangle that's a larger size all by itself, connecting all the pieces basically. And that's 2 times 4 is 8. You add them all together. 2, 4, 6 is 10. 10 plus 6 is 16. 16 plus 8 is 24. And of course, these are all centimeters. So that's centimeters squared for everything. All right. And the next one I will show. All right, boys and girls, the next one is cube. And it's a lot easier to show you. The next couple are easier. The cube, like you would think, it's going to be a bunch of squares. So the easiest way to do it is just draw a square. And then you have to draw the back square. So kind of draw these at an angle. Draw this across. And we come down and over here. Now, it kind of looks like a cube now, but put the finishing touches on by drawing the sides you can't see. So, or the corners can't see, I should say. That to there, that would be the bottom cube, or bottom square, I should say. The bottom square, side square, side square. You'll be able to see the other side square in just a second. Back square, front square, side square. So left, right, top, bottom. Back is here, front is right here. So that's 6. And like I said before, cubes, 6 sides. So anything with a square or a rectangle, 6 sides, these 6 sides. And then a lot of times you'll see a measurement. You might just see one measurement because they're all supposed to be equal. I know I did my best to make this look like a perfect cube and all perfect squares, but it's a little hard drawing it freehand. So when I have 4 centimeter sides and I multiply them times each other, because remember, this is 4 and this is 4, and to find the area of this square, I have to do 4 times 4. So that's 16 centimeters squared. But remember, there's 6 squares. So 16 centimeters squared, I'm going to do this 6 times. And 6. 16 centimeters squared. So you could multiply 16 times 6 if you want, or you could just add them all up. 16 times 6, 6 times 10 would be 60. And then 6 times 6 is 36, so that'd be 96 centimeters squared. All right, boys and girls, last shape, it's called the cuboid or a rectangular. I think of it as a cereal box. You might see it laying on its side or whatever, turned upside down, whatever it is. I just like to, like I said, I think of it as a cereal box. So I guess the easiest way to draw this would be if we thought of the cereal box or cuboid being on its side, I draw a rectangle like this, and then I would draw a smaller rectangle in front, slight angle with these side lines, just so you can show all the corners. It's a lot easier that way. And then it looks more like a rectangle. So then on this back half, this is the part I have trouble with. It has to look like a rectangle, if that does. And then the corners that you wouldn't see is where this comes down and meets, and then this comes up to that corner. So I hope you can kind of see the cereal box here. That's a rectangle. I suppose this should be more angled like that. It would probably look better. That's what the angles are for. Now this looks more like a rectangle. That's a rectangle. This is a set rectangle, rectangle, rectangle. So if I was thinking of the cereal box, this would be the top. This would be the bottom of the cereal box. If it's laying on its side, of course, this would be one of the large sides. This would be the other large side. It'd be sitting on the table with back here. And then these would be the narrow sides right there and right here. But there should be 6 in all when you're counting them, when you're thinking about them. So anyway, to give you some measurements, I added the dimensions, boys and girls. So you have 2 centimeters on these narrow parts. You have 7 centimeters on the length of the top. And then the length of the sides are 10 centimeters. So if I'm going to figure them out, there's basically three different kinds of rectangles. There's the rectangles that make up the large side, this top, or I guess the side that's large, and the side that's, if we're thinking of a cereal box sitting on its side on the counter or something, the bottom here would be that side, and that would be large. And then you'd have this opposite one that's large. You'd have this narrow one, and then you'd have also the narrow sides, the narrow top and the narrow sides. So I wanted to go over them. You have 10 and 7 would be the large ones. So those would all be 70, right? So the surface area of that rectangle would be 70. It's 10 times 7 is 70. Surface area of rectangles is length times width times length, whatever you want to think of the two different dimensions. I have to just do that with all of them. So if I imagine that this one is 2 centimeters, I intentionally put it on this side, but this is the opposite side of that. So this would also be 2 right here. So it'd be 2 times 7, 14. So there's 2 that are 14 because this rectangle is 14 and that rectangle is 14. Then you have the other narrow sides, not the narrow top and bottom. If you want to imagine this a cereal box on its side, but the narrow sides of the cereal box would be 2 times 10 would be 20. So this would be 20. This rectangle here would be 20, and this rectangle here would be 20. And that's keeping in mind, you might say, Mr. Parker, there's no dimensions down here. Why do I even have to figure it out? Well, it's still a side. And when you're talking about these 3D shapes, all these ones with triangles were 5, and the ones that were more squarish or rectangularish have 6 sides. So you have to have the 6 sides. Here they are, 1, 2, 3, 4, 5, 6. And those are all the surface areas of those sides. So to find the surface area of this 3D shape, I just add them all together. So that would be 8. And 7 plus 7 is 14. 15, 16, plus this 4 is 20, 208. And remember, these would be centimeters squared because I multiplied them. And when I add them all together, it's still centimeters squared. All right, good luck, boys and girls. I put as many examples on here as I could that I thought you would see in Khan. I will put the practice for Khan on there. I think there's only 4 questions. Check the videos if you need any help. He draws them out really well on a computer screen. Also go back to this video if you want. Skip around and try to find the areas of how to do each one. Right, good luck. Bye-bye.